Okay, this is an overview of the screen set that I've come up with so far. So there's two new panels I jammed in here between the tool information and the feed rate. And this is a manual control. So by hitting the button here, you can manually control the right and the left servo nozzles. And over here, this is an air blast. I do not have this done yet, but basically it's you just enable it, and this will be the amount of time it's on. So that would be 25 seconds on and 23 seconds off. So you can adjust the on and the off time. Okay, now zoom out here. Up here in the corner, I have a tab for the coolant setup. So that takes you to a new page, and zoom in here. Okay, so down here is the master tool length. This is the overall length of your, basically be the probe or your zero tool. So if this was my zero tool, I'm using paper tools. And so that's the overall length from where it meets the spindle nose to the end of the tool, or the probe, whatever you're using for your master tool. So you put that number in here. Up here, this one is the nozzle to spindle nose distance. This is from the center of the spindle nose where your tool meets to the center of the nozzle. So this is for the right and this is for the left. So this is basically a mirrored setup. Over here on this side, this is for angle compensation. So if your servo turns the wrong way, you can just put 180 degrees in here. So I can just do 180 and it will reverse it. So instead of going from, say, 0 to 90, it'll go from 80 to 0. So that's where you adjust that. This DRO here is the actual angle that's sent out through the Modbus to the Arduino, and this is a manual compensation angle. This is the same as this one here, except for it's used on the manual control. So if you go back here to the main page, it controls this one, so it reverses these controls right here. Okay, and then this is the angle here. This is the angle between the center line of the spindle and the coolant nozzle. So you got to fill that angle in. I usually recommend greater than 90 degrees. Most of the time the coolant nozzles will sit up higher anyway. Down here, this is a clean tool start position. This I don't have done yet. This is going to be for, it'll be like one of those fancy hand dryers you see in the bathrooms, those Dysons with like the air blade, and it will clean my tool automatically. So when it hits 4 inches, it will shoot out a wide blade of air and clean my tool off. But that's down the road. So that's what that's for, and basically over here is exactly the same. And I'll do a demo of how this compensation works. Okay, if I put, say, 10 degrees in here, that will adjust my coolant nozzle by 10 degrees. If I put a negative number in, it will go the opposite. Oop, to go negative 10. Okay, and for this side over here, let's zoom out. Right now I have 180 degrees, so if I have a 0 in here, it'll go off in that direction. So to get it to point the right way, or to reverse it, just go 180, and it'll go back to the correct position. Okay, so here's the test setup. I'll do a quick demo of it working with a program. Basically down here, I'll zoom into this is the setup basically you have an Arduino right here, and this is just an LM 7806 voltage regulator with 2 capacitors. This is the supply for the servos because the Arduino can't handle it, so it's really basic. There's like, you get rid of the LED and the resistor, there's only 3 components to it. So the hardware part is easy as can be. So I'll zoom out here again, and I'll run a quick program. Okay, I have my probe tool in, and all my axes are zeroed. So I will start my program. Okay. It's asking me for tool 32. Tool 32 is a 4-inch face mill. Okay. And then I'll press start. Okay, now the way it's set up is it's designed to go to the edge of the tool, so it uses a triangle. So it's a triangle here to calculate it, and then this triangle to calculate the angle. And so instead of it pointing to the center, which would be, say, in here somewhere like this, it will aim down to the outside edge, because up here it's going to do no good. If it points to the center of the tool, you're going to be hitting up here above the cutter, so it automatically compensates for width and the height. And there's also a manual control. I push the manual button. This allows me to manually control it. So I can aim it manually if I want. And then if I push the button again, it goes back to where it was before. This is a 1/4 inch deep cut. Okay, next tool is tool T90, or tool 90 I guess, and it's got an offset of 5.5 inches, so it's a pretty long tool. So I set that on there. And press start. This is a 2 inch deep hole with a 2/10 of an inch for a 0.2 PEX cycle. Center that up. So the nozzles will always be at the top of the tool, and then it'll pan down to the hole as it retracts out. Okay, this part's sort of messed up because I don't have homing switches, so normally the nozzles would swing down out of the way. This is a really short tool, This has a negative offset. So I'll go to press start. And this is a 1-inch deep slot with a 3/8 end mill, and I think each pass is 0.2, I think. And I have the feed rate really high. And that's the end of the program. So I'll start all over again here. Press start. Take my tool out. It asks me for tool 32 again. And press start. And there it's back to where it started from.